Good morning, Geometry Honor students. So Mr. Chen again. So today we just want to wrap things up for that Unit 7. So it's about one of the special quadrilateral trapezoids. So here's some of the warm-up problem for the parallelogram, such as a rhombus, special parallelogram. So find out the missing measure or the missing angle or the name of it. And also here's the other one, the square. So definition of a trapezoid. So a trapezoid, it's a quadrilateral with one pair of parallel sides. So see the upper base, lower base. So this one they always consider parallel. Okay. So the leg DA, CB. And now sometimes we do have an isosceles trapezoid. If that's an isosceles trapezoid, so that means those two legs got to be congruent to each other. So an isosceles trapezoid is a trapezoid with non-parallel sides congruent on the leg, okay? But the upper base, the lower base, they are still considered congruent to each other. So properties of isosceles trapezoids. If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So the base angle got to be congruent. So let's say this one is A, this one is B. So angle A is congruent to angle B. Okay, and also the one on the top, angle C, angle D. So those two angles, they got to be congruent as well. And also one thing that we notice, the sum of that, the leg, the consecutive interior angles with the leg. So it's always considered 180 supplementary. So angle A plus angle D equals 180. And also angle B plus angle C equals 180. If a quadrilateral is an isosceles trapezoid, then the diagonals are congruent. So the diagonal. Okay, so again, A, B, C, and D. So that means AC is congruent to DB. Or we can just say that, well, this point right here. So let's say the point of intersection, let's say E. So segment AE is congruent to segment BE. And then also this one right here, DE is congruent to CE. Alright, like that. And then the measure of this, the entire diagonals, they're always congruent to each other. So practice. So find each measure. So this one is 63 degrees. So the base angle. So find the measure of angle S. So we do know that this two angle got to be congruent. So let's find out the supplementary angle here. So 180 minus 63. So then that'll be 10 minus 3, 7. 7 minus 6, 1. So 117 degrees. So this angle is 117 degrees. So find the measure of angle M. Angle M right here. So again, using that, the consecutive interior angle. So 180 minus 142. And then you'll get 38 degrees. So trapezoid, find the measure of angle 1, angle 2. So measure of angle 1. So if these two line segments are parallel, so that means the diagonal here will be considered a transversal. If this one is 30 degrees, that means this angle is also considered 30 degrees. So we're using that, the alternate interior angle. So angle 1, 30 degrees. Angle 2, so over here. So angle 2, again, if these two line segments, well, if this one is 30, this one going to be what, 85, right? So for those angle right here. So the consecutive interior angle, so in order to get angle 2, so it's 180 minus the sum of this two angle, so 115. So 10 minus 5, 5, so 7 minus 1, 6. So 65 degrees. Okay, so get the measure of angle 2, 65 degrees. Gotta be careful with this one here. So this one is 30 degree. Okay, so down here, so we're using the Triangle Sum Theorem. So 180 minus 85 minus 65. So then that'd be 150, then that'd be 30 degree. That's right. But the measure of this angle, it cannot be 85 degree because this two angles, they're not considered alternate interior. It's only for those two. So in order to get this angle, so 65 minus 30, because those two angles, they're equal. So that means this angle would be considered 35 degrees. So measure of angle 1, okay, so similar, just like what we did. So this one is 50. So the measure of this entire angle, then that'll be 70. So 50, parallel. This one's parallel, transversal. So this one is also considered 50 degree. Angle 2, so 70 minus 50. So you got 20. Angle 3. Yeah, this one is kind of interesting. Well, the figure is not drawn to scale, so angle 3, then that'll be considered 90. Because that, if you just put it out, it's a right triangle. So 70, 20, 90. And then the measure of angle 4. So this one is the same as this angle here. So 180 minus 70. So it's 110 degrees. Okay. So now let's see what else that we have right here. So find the value of the variables. So df is parallel to eg. Well, df is parallel to gf, excuse me. So df is 4x. Okay, so df here is 4x. And eg is 2x plus 16. Well, yeah, they're congruent because those are the diagonals. So that means 4x equals 2x plus 16. So solve for x, subtract. So 4x minus 2x, 2x equals 16. So x equals 8. So AC, so 7x minus 15. BD, 4x plus 15. So just set them equal to each other. Because that's an isosceles trapezoid. So that means the diagonal, they're always equal to each other. So 7x minus 4x, 3x, 15 plus 15, so we got 30, and then divided by 3, so x, so that equals 10. So midsegment. So midsegments of the trapezoid is the segment that connect the midpoint of the legs of the trapezoid. So basically this one is saying that's the midpoint of this leg, the midpoint of this leg. So there's always a formula for this one. So the midsegments of a trapezoid is parallel to each base, okay? So it's parallel to each base, the upper base, the lower base. And there's always a formula. So the midsegment, the distance of the midsegment, or the length of the midsegment, it's always 1/2 times the quantity of the upper base plus the lower base. In other words, that 2 times m, 2 times the midsegment, so then that'll be the sum of the upper base and the lower base. So this one is kind of like finding the average value. So once you combine the upper base, the lower base, divided by 2, so we're getting the average values of those two bases. So here's the one. So a trapezoid TSQRQ, so TS, so draw the figure. So TSRQ. So we do know that TS is parallel to QR, and use the midpoint. of TQ, so use the midpoint here. And V is the midpoint of SR, connected. So the midsegment. So TS, it's AX plus 34. And then UV, it's 86. So the midsegment equals 1/2 times the measure of the upper base, so AX plus 34. QR, the lower base, so 14x plus 92. And then find the value of x. So combine the like terms. So 1/2 times, so 22x plus 126. 34 plus 92, so it's 126. And then take half of this, so we got 11x. Take half of this, so we got 63. Subtract 63 on both sides, so we do have 23 equals 11x. So that means x equals 23 over 11. So here's another one. It's quite similar. So draw the figure. So trapezoid FGHI. Okay, so J is the midpoint of FI. K is the midpoint of GH. JK, the midsegment. So if JK is 8, FG is x squared plus x minus 2, so using the midsegment theorem. And then IH, x squared plus 3x minus 12. Find the value of x. So again, similar to what we did, so 2x squared, x plus 3x, 4x. Negative 2 minus 12, negative 14. Divided by 2 for each term, so we got x squared plus 2x minus 7 equals 8. Bring everything together to one side, so we got x squared plus 2x minus 15, so that equals 0. And then solve for x, so x plus 5, and then x minus 3, so that equals 0. So x equals negative 5, and then x equals 3. So you probably want to plug in a number back there to check the work, because part of it might be considered the extraneous solution. If you find out that it's a negative number for the side length, which is not possible, then that value of x would be considered the extraneous solution. Okay, so always plug in a number back there. So here's another problem. So in the accompanying figure, isosceles trapezoid ABCD has base of length 9 and 15 as an altitude of the length 4. Find the measure of AB. Okay, so this one is 15, so that means, well, this one is 9. So 15 minus 9 will get 6. So that means the other part of this right here, this one would be 3 and 3. Because 6 plus 9, then that'd be the whole line segment, 15. So we got 3, 4. In order to find out the measure of AB, we're using the Pythagorean theorem, or the Pythagorean triplet. So 3 squared plus 4 squared. So take the square root of this whole quantity. So we got square root of 9 plus 16, which is square root of 25. So square root of 25, which is 5. Okay. And then the other one is quite similar to what we're doing. So this one you guys can figure out what that is. So using that, the information, label it, and then find out the missing segments. So now let's do the proof. So given that ABCD is an isosceles trapezoid, okay, so isosceles trapezoid, so that means the bases, they're parallel, the legs, they're congruent, and also the diagonals, they're congruent as well. So we want to show that angle DAC, okay, it's congruent to angle CBD. So in order to prove those two angles are congruent, so we need to show that the triangle DAC, okay, we want to prove that the triangle, you can show that triangle DAC is congruent to triangle CBD. Or we can prove that triangles ADE is congruent to triangles BCE. Depends on which way that you want. Okay? So let's prove that the overlapping triangle, they're congruent. So ADC and then BCD. So start out with the given. So ABCD is an isosceles trapezoid. So the reason for this one, given. So this one is an isosceles trapezoid. So that means AD, is congruent to BC. So this one is by using definition properties of an isosceles trapezoid. Okay, so another thing that you want to stay here, the base angle. So angle D is congruent to angle C, and also the properties of a trapezoid. Base angles are congruent of an isosceles trapezoid. So we got this. And now another things that we want to show here, segment DC is congruent to segment DC. This one is by using reflexive properties of equality, because that's the same line segments. And therefore triangle ADC is congruent to triangle BCD. And the reason for this one is consider psi, angle psi. So therefore angle DAC is congruent to angle CBD. And the reason for this one is CPCTC. Okay, so here's another proof. So you want to prove that WXYV is an isosceles trapezoid. Okay. So one thing that we noticed, WZ is congruent to ZV. And then XY bisects WZ. Okay, so bisects. So that means this one is a segment bisector. And then angle W is congruent to ZXY. Alright. So in order to show that this one is an isosceles trapezoid, so we want to prove that these two line segments, they're congruent. The base angle got to be congruent as well. Okay, so the way to do it, so this one, so one thing that we can stay here, the triangle. So it looks like we do have two similar triangle here. So we want to prove that triangle ZXY is similar to triangle ZWV. So in order to show that, so let's start with the given. So WZ is congruent to ZV, okay? If this one is a segment bisector, so that means XY, so after the given, so I'm not going to rewrite that. So you can say that XY is the midsegment. Instead of saying that's a midsegment, you can use that as a segment bisector. So that means we can show that these two line segments, they're congruent to each other. So if XY is the bisector of WZ, so we can say that XZ is congruent to WX. And this one is by the definition of a segment bisector. Excuse me. And then another things that we can stay here, angle W is congruent to angle ZXY. So if these two angles are congruent, so that means segment XY, it's parallel to segment WV. So this one by the converse of corresponding angle. Okay, so now we're just proving that these two lines are parallel. And now another things that we can state here, the angle. Okay, so this one is angle. Okay, so angle Z is congruent to angle Z. This one is by using the reflexive property of equality. So one thing that we want to show here is that triangle ZXY is similar to triangle ZWV. So by using this one and also the corresponding angle, so this one can say that triangle ZXY is similar to triangle ZWV by using the theorem of angle. So once we show that those two angles are similar, so that means these two angles right here, they got to be congruent as well. Okay, so this one, so we can say that it's what? Angle ZYX is congruent to angle ZVW. Definition of congruent angles. Well, because that once we prove the similar triangle, that means all those three angles got to be congruent as well. So once we've been able to show that, and also we can say that Y is the midpoint of segment VZ. And the reason why that we know, because that this one is considered the similar proportionality, or the same kind of proportionality. Okay. So we can say that this one here, so segment ZY is congruent to segments VY. Definition of a midpoint. And for the reason for number 8, so why is the midpoint? The reason why that is because the proportionality. And then therefore, so we can say that not triangle, WXYV it's an isosceles trapezoid. Definition of an isosceles trapezoid. Okay. So it's a lot of statements, a lot of reasons. So we've got to be careful with the way to prove that. So once we get the angle, we can show that the line segments are parallel. And this one is the midpoint, while the bisector. So that means those two segments are congruent. So since we showed that those two triangles are similar, so on the other side, it got to be the same kind of proportionality as well. Okay, so this one is a little bit challenging for the proof. And then the rest of the problem, so those are the practice. So you guys are more than welcome to try this. Alright, so some of the problem here, so take a look at that. Okay, quite similar to what we're doing, finding the measure of the missing angle or the missing side length. Trapezoid, the mid segments. Okay, quite similar to the one that we've been going through. And also the proof. Alright, thank you for watching the video today. I'll see you next time.